At this time, we've combined all of our derivative rules, the 4 shortcuts with the 3 larger rules, product rule, quotient rule, chain rule. So the only thing that we need to combine yet is combining my chain rule with higher order derivatives. So the example that I have here is to find the second derivative where it starts out as a chain rule. You should have all of the information that you need to do this problem on your own. So here is where I suggest that you pause the video. Okay, so I have an inside-outside, so I know that I just need to use my chain rule to take my first derivative, f prime of x. My outside function is something to the third power, so that gives me 3 times my something to the second power, where my inside stays the same, 2x to the fourth minus x, and then I multiply that times the derivative of my inside. So the derivative of that is 8x to the third minus 1. I need to simplify this as far as possible if I can. I really can't do a whole lot of simplification here. Note that I definitely cannot multiply anything through here because the exponent. If you choose to, you can distribute your 3 through there. That usually doesn't gain me any ground because I know if I keep it out, that's more of the factored format, which is preferred. So I can't do anything really to simplify here. So that means all I need to do then is to take my second derivative. Now, this is where most students start to make mistakes because in my second derivative, I see this here, which means we have to use a product rule, and that's what students typically try and skip over. If you miss the product rule here, then you're definitely going to miss the derivative of this problem. The other thing that I want to point out is that we have a constant here. So I can just pull that constant out to the side, use my constant multiple rule, and then I don't have to worry about it when I take the derivative. Now, if you distributed it through that here, that's fine. We're going to get the same answer. Your numbers are just going to look a little bit different in the process. So my second derivative then is my constant pulled out to the side, and then I need to do my product rule, where I have the original of the second times the derivative of the first, where I have a chain rule. So I have to bring my 2 down, keep my inside the same, times the derivative of the inside, which gives me 8x to the third minus 1. So this is my first, the original of the second times the derivative of the first, plus, now I have to do it again, the original of the first, which is 2x to the fourth minus x squared, times the derivative of the second. The derivative of 8x cubed gives me 24x to the second power, and the derivative of minus 1 is a constant. So that is the derivative of my second piece. Original of the second times derivative of the first plus original of the first times derivative of the second. Now to simplify this, we of course still have this 3 out in front, so I have 3 times this. Now I can choose to multiply all of this out to simplify it and combine like terms. But if we choose to expand it, it's probably going to expand larger than we want it to, so it'll be extremely difficult to pull it back in. So instead we want to go the opposite route. What we want to do is we want to factor. We want to see what we have in common between those 2 red underlined units. So first let's look at the coefficients. We notice that we have a 2 here, and then we have a 24 there. So we can take a 2 out of both of those pieces. Also, to notice we have in common, we have 2x to the fourth minus x. I have one of them here, and I have 2 of them there. So I can be able to take out one of them from those. Now, I think that's the only things that I have in common, so let's go ahead and write those down. We said we're going to take out a 2, and then a 2x to the fourth minus x, one of those. Okay, now I have to figure out what I have left between my two underlined pieces. Now I know it's looking a little complicated here because I have the double brackets, but I promise it'll get a lot better after this step. So in my first red unit, I've taken out everything highlighted here. That means what we have left over is this 8x cubed minus 1 times itself. In the back piece, I've taken a 2 out of my 24, leaves me with a 12x squared. And then I've taken out one of these units here, so that leaves me with one of them left over. All right, now to simplify, it's going to actually start to look a little better rather than a little worse. In the front, this is all multiplication here, so I can multiply it. I don't need these outside brackets anymore. So I have 3 times 2 to give me 6, times this 2x to the 4th minus x. Inside my brackets, I'm going to FOIL my first red underline. So 8x cubed times itself gives me 64x to the 6th. Outside gives me a negative 8x cubed. Inside gives me the exact same thing. So together that gives me a negative 16x cubed. And last, negative 1 times negative 1 gives me positive 1. Now my back piece. 12x squared times 2x to the 4th gives me 24x to the 6th minus 12x squared times x gives me 12x to the 3rd. And so now all I have to do is combine like terms in these brackets, and then I will be finished. 64x to the 6th plus 24x to the 6th gives me 88x to the 6th. A negative 16x cubed minus 12x cubed gives me a negative 28x cubed, and then plus 1. And then I just need to copy down this here, my 6 times this 2x to the 4th minus x. If you copied it down as is, that would be perfectly understandable. But since we're in factoring mode, we can actually factor it just a little bit farther. If we do a little bit more investigating with this right here, notice that we have a common factor of x involved. So we can actually take an x out of that piece. A 6x, 2x to the 3rd minus 1 times all of this right here. And so that is my second derivative of my problem. So typically the first derivative with the chain rule is not that big a deal. But the second derivative becomes a lot more complicated because it almost always guarantees that we're going to have a product rule. And that's just because of the way the formula of the chain rule is set up. It's a multiplication, so of course we're going to have a multiplication or a product rule if we have to do a higher order derivative.